Hey guys, today we're going to talk about thermochemical equations. We are going to be combining things that you've been learning all year to look at the heat transfer in a chemical reaction. This means we're going to be looking at balancing chemical equations, we're going to be looking at products and reactants of a chemical equation, and we're going to now be looking at this idea of the heat that is either entering or exiting a chemical equation. Okay, so we are combining lots of different topics in one overarching idea. So we're just going to jump in. There's only one way to show how to do this, and that's to actually do it. So for this example, we have how much heat is released by burning 27.5 grams of CH4 given the following chemical reaction. I give the chemical reaction, and now I'm giving this delta H value, or the heat, and since it's negative, it's being released. So chemical reaction, delta H. Now here's our first problem. This value is in grams. But out in front of our chemical reaction, when we have our coefficients, these are in moles. So our first step is to convert grams to moles. And you should know how to do this because we've been doing this in my class almost the entire school year. So in order to convert grams to moles, we're going to use moles equals S mass over M mass. And since it's CH4, that gives me a hint. So moles is my unknown. S mass is 27.5 grams. And M mass of CH4 is a C, which is 12, and 4 H's, which each has a value of 1, so 16 grams per mole. So plug that in to moles, 27.5 over 16. My moles equals 1.71. So that's step 1. Now step 2, we are going to convert moles to kilojoules. And in order to use that, we are going to use this chemical reaction. Each coefficient determines how many moles are needed to make 890.4 kilojoules. So if we look at CH4, there's no number here, so that means it's technically a 1. 1 mole of CH4 makes 890.4 kilojoules. 2 moles of O2 makes the same amount. 1 mole of CO2 makes the same amount. So the whole idea is that these numbers, assuming that the other one is completely available and we don't have to worry about, are going to create the same amount of energy. So since it's asking for CH4, I'm going to use this first value. And I know I have 1.71 moles of CH4. So when I convert, I put that over the fraction bar with a 1 underneath. My second fraction bar is going to use the moles of CH4 in the equation and this heat value. So since the moles are on top, I need 1 mole CH4 on the bottom, and I need this value of heat on the top, so negative 890.4 kilojoules. Now when I math, you multiply across the top, multiply across the bottom, and divide. The moles of CH4 are going to cancel, so I have 1.71 times negative 890.4. So my value of heat, or my delta H, is equal to negative 1,530.375 kilojoules. So essentially, I'm combining reading a chemical formula, this new value of H, this old step of sample mass over molar mass, and this old step of converting, all in one new topic. So let's do it one more time. How much heat is created by using 78.2 grams of O2 given the following chemical reaction? So I'm using the same chemical reaction as the last slide just to get comfortable with it. But now I'm going to focus on this value. So my step 1 is the same. I'm going to go grams to moles. So I have moles, S mass, and M mass. My moles is unknown, my sample mass is 78.2 grams, and my molar mass of O2 is roughly 32 grams per mole. So I'm going to do number of moles is S mass over M mass, which is 78.2 over 32, which equals 2.44 moles. So step 2 is to convert. So again, I'm going to take this value I just solved for, 2.44 moles of O2, and that's going to go over 1 on our first fraction bar. Our second fraction bar, I'm going to use 2 moles of O2 and this delta H value. So since moles of O2 is on the top, I want to put 2 moles of O2 on the bottom, and delta H is negative 890.4 kilojoules. Multiply across the top, multiply across the bottom, and I get 2,175.915 over 2, and when I simplify that out, I have 1,087.95 kilojoules. So my delta H is actually negative 1,087.95 kilojoules because it was a negative 890 in the top. So when I burn 2.44 moles, I end up creating 1,087 kilojoules of heat. So this is the first level of practice problems we're going to be working with. We are going to be using old calculations of sample mass over molar mass and old conversion factors, but relating them to this new idea of using our chemical formulas and our delta H values. So ask questions. You will be confused, and I get that, but I will help. Let me know how you're doing. See you soon.